Hello and welcome to the next instalment in my technical tips. Now today I want to talk about dilution, and I specifically want to discuss dilution in the geological model that underpins the block model of resource estimate. So once the resource model is complete and provided to the engineering team for mining studies and development of the mine plan, dilution is usually considered from this point onwards initially as a benchmark percentage of the ore, but as the studies advance it's given a much more precise value with a spatial component. However, prior to addition of dilution at this stage, there's often inadvertent addition, which is then compounded by the assumption that 100% of the modelled mineralised domain is ore. So this means that throughout the entire ongoing project development programme, there's a hidden waste component masquerading as ore. So how significant is this? Well, in a large ore body with a tabular or ovoid shape, i.e. a porphyry or a laterite, dilution is likely to be around 1 to 5%. Whereas at the other end of the spectrum, a subvertical vein type deposit such as orogenic gold may have up to 40 to 50% dilution in the geological model. So how does one go about quantifying and investigating this? Well, once I've created my geological model, I like to code up the original drill holes or composites by the modelled domains. Then I simply look at the cumulative distribution graph of the assay grade intervals within the grade domain of interest. And the percentage of the intervals below the cutoff grade of the domain is a quantitative measurement of dilution. So why is there dilution? Well, there's three reasons. So there's small intervals of internal waste, there's an inappropriate method of compositing, and there's imprecise modelling around the periphery. What can be done to ameliorate it? Well, what I always do is I check that my compositing intervals are appropriate. Decide whether I want to remove small waste intervals in the mineralised zone, often with recourse to mining method. And most importantly, I tighten up my modelling around the edge of the domain. It can be tempting to include more volume if you're manually wireframing a grade domain, as more volume equals more tonnage. If you're using an RBF, radial base function based modelling software, that will tend out to balloon around the edges without appropriate controls as well. And that can often be due to inexperience. But the key thing is make sure your geological model matches what you see in the ground.